Before watching this video, it is helpful to understand the following terms.
A vector is a quantity that expresses both magnitude and direction. Examples of this are acceleration and velocity.
Velocity. A vector quantity that expresses displacement divided by time. It is speed in a given direction. Mass is the amount of matter an object contains. Matter is the tiny particles that make up objects. No matter the location, mass does not change. Do not confuse weight and mass. Weight equals mass times gravity and changes depending upon location. Weight! Acceleration is the rate at which an object changes its velocity. An object is accelerating if it's changing in velocity, even if it is slowing down, which is deceleration. The unit is meters per second squared because it is velocity times time. Force is a movement, push or pull, upon an object that causes motion. The two objects must interact for there to be a force. No force equals no movement. It is measured in newtons, which is kilograms per meters per second squared.
The force.
Equilibrium is when the net force is equal to zero. This can be an object at rest or moving at constant velocity. Static equilibrium is when the object is at rest. The force of friction equals zero and the force applied equals zero. Therefore, the net force equals zero. Kinetic is when it is moving at constant velocity. The force of friction is equal to the force applied, making the net force zero. Static equilibrium. Kinetic equilibrium.
Newton's first law. An object in motion will stay in motion, and an object at rest will remain at rest unless acted upon by an outside force.
An object at motion will stay at motion unless acted upon by an outside force.
Newton's second law. The acceleration of an object is directly proportional to the net force and inversely proportional to the mass. Acceleration is in the same direction as the net force. This is shown by the equation force equals mass times acceleration. In this example, the force of friction is 5 and the applied force is 10, which means the net force is 5 newtons. The acceleration will be the net force, 5 newtons, divided by the mass, 3.2 kilograms, which makes the acceleration 1.6 meters per second squared. Newton's third law. For every action force, there is an equal and opposite reaction force. As the person pushes against the wall pushes back with an equal and opposite reaction force.
Newton's third law. Francis pushes on Allie.
Francis.
The normal force is the support force, which is perpendicular to the surface the object is on.
The floor is my normal force because it holds me up.
Tension force. Tension force is a force that is sent across a string, rope, cable, or wire when it is pulled tightly by forces on opposite ends. An example of tension is a tug of war when two people are pulling on the rope from opposite ends.
Tension force.
Friction. Friction is the force exerted by a surface as an object moves across or makes an effort to move across the surface. An example of friction is when you're driving in your car and the friction between the tires and the surface of the road that allows your car to accelerate, slow down, and negotiate turns and corners. Static friction versus kinetic friction. Static friction is the force needed to initially move an object at rest, and it only applies to objects at rest. Kinetic friction is the force needed to keep a moving object moving along a surface, and it only applies to objects in motion.
Object at rest. Static friction. I'm an object at motion. Kinetic friction.
The coefficient of friction. The coefficient of friction is a ratio between the force of friction versus the normal force. So the coefficient of friction equals the force of friction divided by the normal force. To show the coefficient of friction, use the mu symbol, and the coefficient of friction has no units. Centripetal force. Centripetal force is the force that makes an object follow a curved path, keeps an object moving with the same speed along a circular path. An example is a ball is pushed into the tube and follows the length of the tube because of centripetal force.
Centripetal